thanks for the intro. I'm just going to get right to it. I was really inspired by Guido's presentation. I love all of the detail and depth and all of the sensors and all the integration on that research. I truly, no joke, I would love to be able to do that in the products that we work on. And I'm excited for all of this innovation to be coming into the mainstream. And, I feel like we're not a passive house focused firm. We're not part of the kind of the movement in the kind of, as far as like being like a friend of mine said, a card carrying member, but we love it and we're glad it's happening. We're in the commercial architecture world. We're still doing buildings for clients that aren't on board with pushing that kind of innovation, and we're trying to find that next client, that client that will help us get where we want to go. We have talked about setting ourselves some goals or standards to meet on a timeline, to get to where we can achieve some of these more kind of innovative standards, and we're talking about trying to get to building a large passive house building within the next 3 years, building a full living building within the next 3 years, things like that. And so as we've been working on the vision for the firm, we've committed just recently to kind of this list of ideas here. We want our firm to be more aware in all the work we do. We want the work that we do to be more harmonious, more regenerative, more clear, more simple, really, more innovative, and then lastly, more like art. And so for us, these are kind of the foundations of what we're interested in and passionate about. And just want to ask everybody, this question. I think the answer is yes. Like we all love wood, right? And so do we. And so we've been building in wood forever. This firm being in the Pacific Northwest, it's like it's the material that's just so ubiquitous, but it's much more than that. I mean, for us, I think all of us that live in this bioregion, really, the forest defines our home. We all have experiences in the landscape here that I think weave themselves deeply into our life experience and how kind of we define our memory. And so that's really important to this material for us. It's very personal. It's part of a long-standing tradition. It feels good to be working with the material and with spaces that feel like they come from this landscape, and that they've been here for a long time, and that we're not the first. We barely even know what we're doing. There's people out there, such as the Northwest Coast tribes that have been working with wood for much longer than any of us have and really understand what it does and how to work with it. And I think that personal connection that we all have is really important, so how we each develop our own relationship with the material. And this is an image that I have of a sculpture that I carved many years ago, but just that experience of working with wood in that intimate way, and also working with wood that was reclaimed from a mass timber warehouse that was being renovated, is really important to me. And I know that we all have experiences like that. And so when we work with wood, it's special. It's not just a structural material. And I think for our firm, the bottom line is that we'd all rather be outside. And so we're trying to design buildings that feel connected to nature and are of nature. And wood is that material that connects us. And then the design form that we bring is the way that we really blur the boundary and make it so that no matter where we're working, we're bringing the landscape inside. And so, this is our office in Southeast Portland, basically in downtown Portland. We're not the owner of this building, but we're the anchor tenant, and it's a mass timber CLT glulam building. And our goal is so that even when we're working in a tight urban environment, we're trying to find ways to bring connections to the landscape. So no matter where we are, whether it's a sensitive natural site somewhere in the high desert, or in downtown somewhere, we're trying to find ways to connect people to the landscape. And so this material does that for us, along with, like I said, the way that we design. And so we also bring wood and bring nature into really unexpected places. Like this is a National Guard armory in the Willamette Valley, kind of in the middle of Oregon. And it's a place that you wouldn't expect to have a connection to landscape. And so even this place for military exercises and training, we brought this connection to the landscape to it because we felt like the people that are working here and experiencing this building could benefit from that, and it could impact and affect the way that they do their work, the way that they see the value of their work in the community, and the way that they approach their operations. So we've done a lot of mass timber buildings, but it's not just new buildings. We've renovated a lot of mass timber buildings because I think, like Guido was talking about, is it's one of the older ways of building, and it's part of this long-standing tradition. And so it's really valuable both from a repurposing and also a new construction standpoint. And of course, we've done a lot of new buildings. Some of them are mass timber, some of them are just clad in, this one in the upper right, in Oregon white oak from the Willamette Valley. So it's just things like that that are ubiquitous and really important to us. So, and I was asked to talk about making the case for mass timber for academic and public buildings because we do a lot of them. And so I think something just that everyone in this world should be aware of is that it's becoming a priority for governments. The 3 governors in the Pacific Northwest all have an agenda and a climate action plan that addresses their interest in their passion for integrating timber into buildings as much as possible. It's really cool here to see how mass timber can bridge communities right now, especially in the political environment that we're all existing in. The urban-rural connection is really super important. I come from a long family of loggers, and it's interesting to see how the divide has just become harder and harder, and the perceptions of those communities from one to the next is oftentimes incorrect. And so mass timber is a way that we feel like we can personally make connections to our rural communities in really important ways. We're starting to find ways that these projects, and Guido's is working on, is a great example, that these projects that we're working on and this product that we're trying to help develop can start to make those connections. The institutions that we work with are also involved in the design and testing. Again, Guido's presentation is paramount to that. So there's all this research being done in all these different places that we already have as clients, and they're passionate. Their wood research programs are actively working on how to integrate these products into buildings and doing testing and working with manufacturers to try and develop better ways of doing things. As we all know, but it's important to just highlight for the academic world, is that mass timber is really, it's proven. We all know it at our core, but there's also data that shows us that being in a space elicits this biophilic kind of response from everyone that is actually testable, and they can show there's actually a physical and psychological measurable benefit to working within a space that is built out of wood, or that has some large part of that building made from wood that you can see. This is this debate. There was there was a chat going on, right, about how much energy is really embodied in all these materials. But I'd love to get to the bottom of this. When we're working with Scott Ellert in California on his fabric product, we're helping him design that. And we're talking about all of California's perceptions about embodied energy in their materials and where they're sourcing their materials and how can they use the material that they have that's just sitting there and going to waste maybe. So it's really important. And I think the big point here is that generally speaking, we're pretty convinced that the same material, the same element, piece of a building, a column or whatever, built out of timber, uses way less energy overall than a similar element made out of steel or concrete. And that timber stores carbon. This idea that it's the only renewable building material, and that every chunk of timber that we use is actually sequestering an amount of carbon that has impact that's beneficial to climate change. So just this slide is really cool. We built a building in Hillsboro, Oregon, kind of near Portland, near where all the Intel work and all those microchip fabrication plants are. We built an office building for a client that was a bank. And this building, saved a lot, stored a lot of CO2. It has equivalents of like how many cars it pulled off the road. It's 1,200 cars. It's saving a lot of carbon. So the really interesting thing is that when we talk about how long it takes our timberlands to grow this wood, just for Oregon timberlands, we're not even talking about the whole country or the whole region. We're talking 46 minutes is how long it takes Oregon timberlands to regrow the wood that was used in this building, and we just love that idea. Something that is really important for these types of buildings is that the structural system needs to be different because of the spanning capabilities of the materials that we're working with. So we're not working with normal structural grids, like 30 by 30 grids, the steel or concrete building or what have you. And so we have these narrower grids in one direction and then maybe longer spans in the other direction. So we have 30-foot, maybe 40-foot spans sometimes, and it creates this nimble structural bay that can be really flexible. It can be scalable more easily, and it can be adaptable. It can be phased more easily. Because it's small, the module of additional bays is smaller. It doesn't take up as much space. It's a really, really clear, blank, beautiful slate. And so this is just kind of a rendering showing a fundamental layout that we have been developing over several projects, where we have a long span in one direction and then in the other direction a short span. So say a 30-foot or 40-foot span in the long direction supported by big, deeper glulam beams. And then we have CLT or mass plywood spanning in the other direction at say 10 foot, 12 feet, 15 feet. It all depends on the building and what you're trying to do and how efficient you're trying to be with the fiber, the wood fiber in the building. But you can see on the left in this image, that kind of open space. We call that section the colonnade. We use that section typically for running mechanical systems, and then we run those ducts and piping and things out into each bay. So you're actually visually screening those ducts and those systems when you're looking down this sight line in the space like this. And then you can see the little notches in the ceiling. Those are where we have actually spaced apart the structural panels to allow other smaller mechanical elements to run through, sprinkler piping, data lines, electrical conduit. So these types of layouts are really useful for a range of spaces. So for instance, classroom spaces, you can see the circulation of the hallway on the left. You can see how you've integrated mechanical systems between the panels up on the ceiling there. You can see how lighting is dropped into those spaces. And then the side benefit really of the way that this is structured, on the right, you can see the window head goes all the way to the ceiling because we don't need a perimeter beam, the way the structural system is functioning. And so we can wash light really seamlessly into the space, reducing glare and making these overall really pleasant spaces to be in. We can make a visual art space out of these spaces. This shows a little bit higher ceiling, depending on what you're trying to do. You can make a lab space, so tech spaces too. Vibration is a concern, so we have been doing research on what it takes to get lab spaces built within mass timber buildings, and it's possible. It does add a little bit of cost to the structure, but not unreasonable. And so we have a lot of examples of the types of spaces that we have built using mass timber, and some of them are from a while ago. This is the Hallie Ford Center at the Oregon State University campus. We've built long span systems like this gathering space at First Tech in Portland. We have built administrative and faculty space using kind of different ways of structuring. See, that ceiling is a different structure. That's got a more traditional kind of structural system with a beam at the perimeter, different than our CLT designs. This is an older project. This is a newer project. This is the Canyon Commons at George Fox University. So a dining space, a long span system. You can see using how you use that 40-foot span to create spaces like these. Something to know, that's really important is that you have a light building. They're lightweight buildings. They're much lighter than concrete and steel buildings. You have a light and fast crew. And so what's really interesting is our First Tech building, it was 150,000 square feet, and it took a 7-person crew and 1 crane operator 12 weeks to assemble the structural frame for that building. And it was almost dead silent on the site, relatively speaking. So it takes less space. So for tight sites and campuses where you don't want to interrupt people and activity around the building, it takes less space because you have less laydown space. It's, like I said, a really peaceful, quiet, relatively construction site. When I went out to the First Tech site, during construction, and I took my son out there. We went out there, and he was really young at the time, but he said, "This is this a construction site? This looks like a park." And so it's really amazing how different it is and how quiet and efficient it seems. It's really clean too. So it's just a beautiful construction site. It's really fast. To quote Lightning McQueen, faster delivery dates allow for more schedule flexibility to align with the institutional calendar. So all of these types of projects can benefit from more precise planning of when they can occupy their buildings. And if you can do it right, just like we did at First Tech, we built a building that was 4% less expensive and 4 months faster than the equivalent steel building. So some things to know, really important to know when you're thinking about this. First, it's not just beautiful, it's a 3-in-1 system. Number one, it's the structural system. Number two, it's also its own fireproofing. Number three, it's also its own finish. So you're saving money if you design it right by considering this reality. And so you don't have to fireproof your structure. You don't have to finish it. What you see is what you get. It's beautiful, structural, and it's complete. But you've got to plan for that. People want to touch it. People want to touch everything in the building. And so we've been doing mass timber buildings for a long time, and we've been going back and photographing what happens to them over time. One of the things too, in addition to touching, is just that furniture and other objects impact the buildings. And so you can see on the right side here, this is the Hillsdale Public Library in Portland. You can see some damage that has been done from chairs that were higher than the chair rail that we installed that you can see on the lower right. So you've got to kind of plan for that. Wood is more dynamic. It tans, it has sap in it, it dries, and it fades. It changes over time. So we've been documenting and looking at how these things change. It's not any less beautiful, but making sure that you can share with your clients that this is going to change is really important. Acoustic ratings are still in development. There aren't as many tested assemblies for how you mitigate sound transfer, all types of sound transfer from one space to the next. And so when you think about that, you've got to know that it's important to work with an architect and a builder that understand that and understand how you're going to mitigate sound, and that it's going to be a little bit different. And acoustic design is specific to mass timber. We do it in different ways because if you want to expose your wood, it also happens to be a kind of reverberant surface. So acoustically, you've got to think about that and plan for it. Mechanical systems can really inform the layout. And you can see these kind of 4 examples on the upper left, the conventional under the beams system that normally happens. Below that, the beam and purlin system where the mechanical system can kind of go over the beams. We have done the 2 on the right in mass timber buildings to try and mitigate the issue of penetrations through these structures and try and make the structure as integrated with its mechanical system as we can. So the raised access floor on the right, we did that at the First Tech office building that I shared. And then on the lower right here, you can see this one-way beam and colonnade system. That's the system that right now we're favoring for a lot of different reasons. Like I talked about, it's more integrated, it's visually more screened, and it's also less expensive than a raised access floor. The lateral systems you can work with need to be considered differently. Right now, really, there aren't that many that are cost effective, and steel brace frame is really what we've been kind of leaning on. We've done concrete shear walls too, but given the loads and the sizes of these buildings and the seismic zones that we're working in, those 2 systems tend to float to the top. We want to push for an all wood lateral system. As I think people know, that's in testing right now, and there have been a few buildings that have done it, and it's only a matter of time before we can easily build an all wood lateral system. You got to follow the changing code. So, I mean, just as Gita was mentioning, it's in Canada, it's different than here. In the US, the proposed new code allows higher buildings with more exposed wood. And the next code that's coming out in a few years is going to allow even more exposed wood. So Oregon and Washington are kind of early adopters. And so these codes currently have been adopted here, and that's what's allowing us to do what we've been doing. But it's only a matter of time before that's going to be adopted by more states. And then there's going to be another code revision that will take a little bit of time, but that then will be adopted. So it's looking really good. Modeling is critical. So you've got to have the right contractor, and you've got to model everything. And so really coordinating your mechanical penetrations and how you lay out your mechanical is important. At the First Tech building, we had over 4,000 holes that were pre-drilled in all of the structure and not a single mistake. amazing. And I owe that to, the work on between the entire team. And so Eric is going to talk about that next, but it's because of that type of collaboration that we're able to do these things efficiently. And getting back to Guido's point about technology helping us make these things possible, the contractor is your partner, the ability to prefabricate and kind of mass customize these components before they come to the site is really important. At the First Tech building, which at the time was the largest mass timber building in the United States, we only had 4 columns that were machined incorrectly, and Structurlam got them to us in a couple days remachined. It's amazing. We still have a lot of work to do. This diagram on the right shows a study that we did for a big project that we were doing in San Francisco, the Pier 70 project. It was going to be the largest mass timber building in the US. It's been put on hold, but it was 320,000 square feet, working with Swinnerton on that project. But you can see on this diagram here that the timber is only a part of the impact on the amount of carbon that's released, building these buildings. And so what do we do about that? We've got to think about that. There's still steel in these buildings. There's still concrete in these buildings. And the source of that wood also makes a big difference. We did a pretty in-depth study on comparing the sourcing of the timber for that building from a domestic source in the US versus getting it from Austria. And it increased the impact big time, just the shipping and all of the work to get that material to the site. You got to understand that the supply chain is evolving. I mean, it's this map may not even be up to date. I think it's pretty accurate. If anybody knows of anything that's not on here right now, the point being is that it's changing all the time. There are other manufacturers abroad you can get this material from. They have maybe a 10 or 15-year head start on all these companies here in North America. But this is ramping up quickly and making projects in different parts of our regions more viable as we speak. So I think it's really important to emphasize that you've got to get an inspired general contractor that's excited about mass timber, that's ready to be a true partner, and you got to get them in early. This doesn't work unless they start on day one. As soon as you start designing, they're in the room with you talking about this project, because they have got to work hard up front to manage all the supply chain and to be able to achieve the schedule benefits of mass timber and prefabrication. And you got to use it in the right ways, in the right places. Not all buildings should be 100% mass timber from the ground up. This is a study we did for a building, an academic building in Tacoma, Washington, showing that we had a couple floors of concrete and then we built mass timber above that. And it made sense for the types of spaces that were happening in those concrete levels, and then the types of spaces that were happening in those wood levels. So you want to put the money where you want to see it. You want to, the mass timber structure probably costs more than the alternatives of steel and concrete right now. But who knows, with the way things are changing all the time. But you just don't want to bury that money underground. It's a lighter building, so the heavier concrete and steel structures end up putting a lot more of your investment into things you can't see, like foundations. So I went through that as quick as I could. Thanks for your time. And if anybody has any questions, I'd love to hear it.
Am I good? Can you hear me?
Yeah.
Okay. So we have a couple of questions, Corey, about LCA. I think we'll save those for the end because it's part of the larger question I have for the panel discussion. The connection for me, I think that you hit on that was really interesting and that we talk about a lot too, is the jobs and government. And with the new European Bauhaus, the Green European Deal, a number of jurisdictions in Europe, I think British Columbia as well, have started pushing the utilization of wood as part of a component of climate protection. And I think you're starting to see that on the West Coast. Are you in discussion? Is Hacker in discussion with jurisdictions or anybody of that nature on things like this?
Yeah, absolutely. I think near Portland, Clackamas County is a big one, and they're really investing in their infrastructure to try and build capacity for producing CLT and other mass timber products. And so we have been in meetings with them and helping them understand what we know. And then also we're learning a lot from them about how they see their supply chain and the harvest working. And they've been giving us tours of their timberland and with their timber managers. And so it's a kind of a collaborative effort there. And that's also what we love right now about this industry, is that it's kind of an open source dynamic where everybody's willing to share everything, and everybody wants to know. There's no one's kind of keeping their secrets hidden. Everybody's trying to help further the technology.
And we have one question from George. I believe George is in the UK. Have you at Hacker explored hybrid timber concrete floor systems for enhanced fire and acoustic performance?
Yeah, we have, and we've done them. So it depends on the fire rating you need, the acoustic um, conditions you want to create, and just the finish you want to see. So yes, we have not explored hybrid concrete like precast systems like the building that was just built at Adidas yet. That's very interesting, but really we still feel pretty strongly that that was done for schedule reasons more than for other reasons. So we're pushing when we can to try and minimize the use of concrete in the buildings that we're designing.
That is good to hear. Yeah, and I do believe that was kind of pushed more towards dealing with schedule and parking and
Yeah.
things of that nature.
Yep.
So
I mean, which is great. They achieved something really innovative, and they did it really well, and it was a collaborative effort to come to that decision. So great.
that was great, Corey. Next up.